All right. Hey, everybody. So in this quick video, we are going to introduce a new kind of series, so-called alternating series. Our big goals are to introduce what an alternating series is as a concept, so you can begin to identify them, and to examine the most, probably the most famous series, alternating series of them all, the alternating harmonic series. Let's get into it. So simply put, a series is said to alternate if subsequent terms alternate their sign plus or minus, right? So each term is sort of positive, then negative, then positive, then negative, and back and forth, alternating between the two. So a nice way that we can represent this is to write our series of the form A1 minus A2 plus A3 minus A4, like this, so that every even term is negative and every odd term is positive, right? So we can write it like this, where notice the individual expressions A sub n, or A sub n is a positive expression, right? And so the idea there is going to be that if A sub n is positive, if it's a positive number, then this is truly positive. While here I'm subtracting something positive, that makes it negative, plus something positive, minus something, plus something, minus something, and so on. I can write this using our standard notation as the sum, as k goes from 1 to infinity, of expressions of the form, so we have our a sub k in there, but I also include this term here, negative 1 to the k minus 1, right? And notice that negative 1 to the k minus 1 is indeed going to give us this alternating expression. When k is even, we have k minus 1 is odd, and so negative 1 to an odd power is negative, while when k is odd, k minus 1 is even, and so that first term will give us something that is actually a positive one. I should just point out that, of course, we don't have to start with a positive number. We could also have negative a sub 1 plus a sub 2 minus a sub 3 plus a sub 4, and so on. And in that case, we would end up with basically the same expression. Sum, k goes from 1 to infinity. Just this time, it would be a negative 1 to the k times a sub k. All right, great. Now, the most famous of all of our alternating series is the alternating harmonic series. And remember, the harmonic series was the expression of the form 1 plus a half plus a third plus a fourth plus a fifth, dot, 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 and so on, right? So our alternating harmonic series, or I'm sorry, our harmonic series by itself was expressions of the form, or was the series of the form 1 over k. So when it comes time to talk about the alternating harmonic series, I have my original harmonic series, right? That's my 1 over k, but I make it alternating by introducing this negative 1 to the k minus 1. And so this is my alternating harmonic series, 1 minus a half plus a third minus a fourth, and so on and so on. Now notice, and this is kind of interesting, the original harmonic series, it diverged, right? It diverged very, very slowly, but 1 plus a half plus a third plus a fourth plus a fifth, and so on, very, very slowly crept up towards infinity. What happens in the case of the alternating harmonic series? Well, to examine this, we can look at the sequence of partial sums, right? And so we can calculate S sub 1, right? That's the first partial sum. That's just equal to the first term, so that's 1. That will be this point right here. S sub 2, right? That's the second partial sum. That will just be 1 minus a half. So that's 1/2, 0.5. That's about right here. S sub 3, well, the third partial sum, that's 1 minus a half plus a third. And so that's going to be approximately equal to 0.833. Right, so we started at 1, we did minus a half, now we're doing plus a third. and we'll get up to just about 0.833. Notice we didn't quite make it as far up as 1 again. Let me go ahead and label these. So this is S1, and we bounce down here to S2. Now this one here is S3. If we go one more, let's say S sub 4, well, S sub 4 is going to be 1 minus a half plus a third, and then minus a fourth. So we'll subtract a fourth, and we'll get somewhere down around here. In fact, S sub 4 is approximately 0.5833. And so that will be right around here. It's S sub 4. Right? And let's do one more. S sub 5. Oops. S sub 5 is going to be, right, that whole thing, 1 minus a half plus a third minus a fourth, and now plus a fifth, and that will end up being right around 0.783. All right, and so that will be right around here. And now notice, right, you can start to see a pattern here. Every single time we add or subtract the next term, we're going to bounce a little bit to the left or to the right, but we're not going to go as far as we had previously been. To go from S sub 3 to S sub 4, we subtract an entire fourth. We go back to S sub 5, we add on a fifth. And so we're not quite going all the way back up. So you can imagine, as I continue adding and subtracting these different terms, I'm actually going to get terms that sort of keep bouncing in and bouncing in and bouncing in, never quite escaping or getting past the previous two terms. And so in fact, this infinite series will converge to some number in here. And it turns out the alternating harmonic series converges even when the original harmonic series diverged. All right, really interesting juxtaposition of the two. And we'll explore that more in a subsequent video. I want to end this video just by highlighting that just because the alternating harmonic series converged does not mean that all alternating series converge, right? And here's a great example. This is just the term -1 to the n minus 1. This is 1, minus 1, plus 1, minus 1, plus 1, minus 1, and so on and so on. Here you could think of all of our a sub n's as just equaling +1. And we see that if we look at the sequence of partial sums, right, and I think we've already done this, you see that S sub 1 is 1, S sub 2 is 1 minus 1, S sub 3 is 1 minus 1 plus 1, and so on. This thing diverges because it never actually settles towards a given limit. The sequence of partial sums fails to converge as a sequence. And so this infinite series diverges. All right, that's all I got for you for this video, but I will see you all next time.